So, what is work? Work is basically a transfer of energy from one form to another. So, we can have electrical work, we can have gravitational work, we can have pressure volume work, what we deal in chemistry. Alright, we have different formulas for work. For example, you must have studied in physics that work equals to force into displacement, right? And similarly, if you have gravitational work, that is equals to mgh, and electrical work equals to charge into potential difference qv, and mechanical work which we will be studying in chemistry is pressure volume work, that is p delta v. P is external pressure and delta v is change in volume of the gas. All right, so we have a derivation out here. So what does this tell us about? This tell us about a constant pressure applied for a change in volume from V1 to V2. So the changes in volume is delta V, and when you apply pressure, external pressure, that is P external, then P external into delta V gives you value for work done. Alright, so just remember this formula: work done equals to pressure into change in volume, that is delta V, right? Now what, why, you must have seen some places that the work done equals to minus P delta V. Why we use that? For that, I would like to tell you sign convention. We in thermodynamics we do have sign conventions. What is sign convention? That means we have decided if work is being done on the system, we will take a sign as positive for work done. If work done is by the system, that means work is being done by system is doing work, then sign of work will be negative. And similarly, if heat is absorbed by the system, heat will be positive. If heat is given out by the system, the sign will be negative. For example, I'll show you through a graph or a figure rather. When work is being done on the system, that is positive sign, and this will be compression of volume. We are imagining a system which is gaseous system, right? So work done by on the system, sign is positive and the process is compression. Similarly, when gas expands, then work is being done by gas, and the phenomena is expansion of gas. Expansion is happening. Similarly, if a system absorbs heat Q, then sign of Q will be positive, heat absorbed by the system, and if heat is released by the system, then sign will be negative. All right, so these are the signs we have decided in chemistry. So similarly, if we have work done by the system, that means gas is expanding, that means sign should be negative, right? To get the proper sign according to sign convention, we are using this negative in our formula. All right, so work equals to minus P delta V. So that gives us the exact sign which we need according to our sign convention, which I explained over here. All right, so sign convention is mentioned here, and I have discussed on this slide as when work is done on the system, that means we are compressing the gas. So sign of work done W equals to plus. And similarly, when gas is expanding, that means gas is doing work. We are not doing work. We are doing work in compressing. When gas is expanding, that means gas is doing the work. System is doing the work. Then sign will be negative. So you can use the formula minus P delta V in your numericals to get the exact value of work done. Alright. Then there comes another term called internal energy. So what is internal energy and what is external energy? If I ask you what is your internal energy, so that means the energy within. Similarly, for a system, internal energy is the total energy, all the forms of energy inside a system. That means chemical energy, kinetic energy, potential energy, vibrational energy, rotational energy. You add up all forms of energies of a system, that will be called as internal energy of a system. Internal energy of a system is state functions. Alright. So, for a cyclic process, state of the system does not change. So, delta U equals to 0 for a cyclic process. Alright. And how it is calculated? You add up all forms of energies of a system, you get internal energy. So, I have a question for you. What do you think? Which is gravitational energy part of internal energy or not? No, it is not part of internal energy. Why? Gravitational energy is the pull by gravitation by Earth, right? So it is part of external energy, it is not part of internal energy. Can you calculate absolute value of internal energy? No, you cannot calculate U. The symbol of internal energy is U. So you cannot calculate U. What you can calculate? You can calculate change in internal energy. So delta you can calculate. We have formulas for that, not absolute value, that is U. So we cannot calculate internal energy's absolute value. We can calculate decrease in internal energy, increase in internal energy, or change in internal energy. Alright. We have last, zeroth law of thermodynamics. What is that? Zeroth law of thermodynamics says if you put two different bodies in contact with each other, so one hot body, one cold body, then heat transfer takes place. After some time, both will be in equilibrium. That means there will be no net flow of heat, right? Similarly, this is called, when there is no net flow, this is called thermal equilibrium. When two bodies separately, let's say A is in thermal equilibrium with B and B is in thermal equilibrium with C. A is in thermal equilibrium with B, that means no heat transfer between A and B is in thermal equilibrium with C. Then A and C will also be in thermal equilibrium, right? So this is what zeroth law of thermodynamics means, that if two bodies are separately in thermal equilibrium with the third body, then the two bodies will also be in thermal equilibrium with themselves. So this is it.